Today we're going to be talking about the moment generating function of a Poisson distribution. The definition of the Poisson distribution, or the moment generating function of a Poisson distribution, is to calculate the expected value of e to the tx. Well, expectation means that we sum everything from minus infinity to infinity of what's inside the expectation, e to the tx, times the probability. Here the probability is known. It has this known formula of e to the minus k times k raised to the x power over x factorial. And here this probability only applies for probability starting at 0, so the sum goes from 0 all the way to infinity, because those are the range of values that the density function applies. Now this constant here, k, is equal to a constant. Therefore, e to the minus k is also a constant. So I'm going to move that piece outside the summation. It's just a number. So this will be e to the minus k times the summation from 0 to infinity of k to the x times by e to the t times x over x factorial. Now everything in the numerator that has a power of x, so I'm going to rewrite that as k times e to the t all raised to the x power over x factorial. And then I'm going to use a convenient little fact about exponentials. E to the z, it has an infinite series representation. And its representation using its Maclaurin series is going to be 1 plus z squared over 2 factorial plus z cubed over 3 factorial plus z to the fourth over 4 factorial. And this never ends because it's an infinite series. So if we wanted to write this infinite series, is going to be z raised to the x power all over x factorial, where x starts at 0 and goes to infinity. So if we plug in x equals 0, we get 1. If we plug in x equals 1, we get z. If we plug in x equals 2, we get z squared over 2 factorial. Okay, so this is going to be e to the minus k times, now z is everything that is in the power there, so this becomes e to the z, okay, and I'm just going to highlight this. This thing is z right here, okay, so this becomes e to the z, where z is k times e to the t. Now, just by since they both have base e, this is going to be k times e to the t, and then we can add the exponents. In this case, it's going to be minus k. You can write this as k times e to the t minus 1. Okay, and so this is the moment generating function of a Poisson distribution.